Hello, Mr. Eric, Mr. Ryan, are you alright? Okay, we're given an array of integers and we want to count how many pairs. A pair is two numbers.
Yes, I know that.
We're given an array of integers. We want to count how many pairs that the sum of it is smaller than the target. This target is given. Okay, so for example, given this array, we have 3 pairs. 2 plus 3 is smaller than k. 2 plus 3 is smaller than k. 3 plus 3 is smaller than k. So there are 3 pairs. You need to tell me it's 3.
3 and 2.
Because I is smaller than j. Okay, so 2, 3 is the same as 3, 2. So we only count it once. That's a very good question.
So what? How about 3, 3?
3, 3, yes, yeah.
Yeah, but let's say the left one is first. Then why not the right one be first?
Yeah, the same reason. I is smaller than j. Ij,
Yeah,
ji is counted once.
Yeah, but I isn't smaller than j.
No, I is the index, is not the value. This is the index. Ij are index, so 0, 1, 2, 3.
Yeah.
Okay, so can you solve this problem?
Okay.
How
So
do-
this is how you do it. So this is how you do it. So, be quiet, okay? We sort it, right?
Sorted, yes?
Yes.
Okay, you mentioned a very good point.
Yes,
Okay,
yes,
this
yes,
array.
yes. So you pick the first 2 numbers.
Yeah?
Yeah. Yeah.
Why first two numbers?
Because you will create the smallest sum.
The first 2 numbers. The array is unsorted, but you say, okay, let's sort it, okay? Sort it. Oh, and again, right?
Yeah, I know.
Okay, so if we don't sort it, what can we do with it?
I'm talking about my approach.
Okay, so what's your approach? Sorting it, and
And then pick the first 2.
then
And then
why do we need to sort it, by the way? What's the advantage if you sort
so
it?
you get smallest to biggest.
The smaller, biggest, yes, and okay.
That's what we want. Yeah.
Let's write. Okay, so let's look at this problem. 2 sum. Finding the 2 numbers. So let's say we want to find out if there are 2 numbers that add up together to 7. Okay, so how can we solve this problem?
Brute force.
Brute force is a good way without sorting, but I'm talking about if we sort it. How can we find out if the number, let's say, okay, so if we want to find out that the 2 numbers added up to 6, for example, how can we do it? If this array is already sorted, how can we find out if there are there's a pair, any pair that added up to 6? If we sort it, okay, so 2 plus 5, 7, and we're looking for 6. So what should we do? Move the left or right?
Move the right one left.
Move the right one, and then now 2 plus 3 is smaller than 6. What should we do? Move left or right?
Left. And get that.
This is 2 sum, finding the exact sum. And this now we're just counting the pair smaller, adding up smaller than 6, okay? So the reason we sorted it because we want to use 2-pointer thing. This is the 2-pointer. Okay? Now 2 plus 5, for example, if we want to find out that if any pairs that we want to count how many pairs that sum is smaller than 7. Okay, 2 plus 5 is not less than 7. So what should we do? Move left or right? 2 plus 5 equals 7, but we're looking for the sum smaller than 7.
Left. Right, left.
Okay, now 2 plus 3 is smaller than 7. So what should we do now? We want to count the pairs that the sum are smaller than 7. 2 plus 3 is smaller than 7. How many pairs?
Then you check the second one, and then you also have 1 pair.
Yes, there are 2 pairs. Right, look, 2 plus 3 is smaller than 7, right? So we can move this to the left. But also it means that 2 plus this 3 is also smaller than 7, am I right? Because look, if I move the right pointer to the left, the sum will become smaller. Am I right? The sum will become smaller, so we have pairs. So if this is index I, this is index j. So when array I plus array j is smaller than k, we have j minus I pairs. Am I right? We have j minus I pairs, and we need to move the right pointer to the left. If it's bigger than 7 or equal than 7, we move this thing to the right. We're moving the left pointer to the right because this sum is already smaller than k. So there's no point to keep moving the right pointer to the left because the sum will become smaller anyway. So we need to add this number of pairs. So
but you can still check.
yeah, I don't because the answer is to count. I already know how many pairs. I don't need to continue checking, right? Okay, so 2 plus 3 is smaller than 7. So we move this 2 pointer to left pointer to the right. So it's 3 plus 3. 3 plus 3 is smaller than 7. So the number of pairs is j minus I, which is 1 pair. Okay? This is quite similar to sum, finding the exact sum in the array. Okay? The reason we want to sort it is because that we can use the two pointer. Without sorting, we can apply the brute force. Brute force, just brute forcing all the pairs takes O(n) square time, right? For I in range n, for j in range I, answer equals 0. Then if array j plus array I is smaller than k, then answer plus equal 1. Return answer. This is brute force, right? The time complexity is O(n) square. O(n) square. There's an n loop here. There's an n loop here. This is O(n) square. Okay? Yeah, you should be able to write this. This is brute force. Yeah. But we want to use the 2 pointer thing because that's quicker, right? Sorting is O(n) log n. This is quicker than O(n) square. Once we have the sorted array, we can use the 2 pointer thing. So array.sort, this is going to take O(n) log 10 time. The left pointer is 0. The right pointer is the length of the array minus 1. Answer equals 0. While L pointer is smaller than the right pointer. While the 2 pointers not meeting each other, right? So then we say if array L plus array R is smaller than K, right? If it's smaller than K, then we know the answer plus equals R minus L. Then in this case, we need to move the left pointer to the right. Otherwise, if the sum is bigger or equal than K, that means that we need to move the right pointer to the left, right? I minus equals 1 and return answer. Okay, this is the 2 pointer thing. This is the 2 pointer. Look, sorting O(n) log n. O(n) log n. And this while loop is O(n). Why is it O(n)? Why this loop here is O(n), the linear? Left pointer and the right pointer. Why they not meeting in the middle, right? At the beginning, the left pointer is left, the leftmost. The right pointer is rightmost. At each iteration, what happened? We either move the left pointer or we move the right pointer. So when they meet in the middle, the total number of steps is n, right? Right, look. If the sum of left pointer plus right pointer is smaller than k, then we have R minus L pairs. And then we need to move the left pointer to the right. Because there's no point to keep moving the right pointer to the left because the sum will get smaller. If the sum is bigger, what should we move? We move the right pointer to the left, right? Because the sum is bigger. If we move the left pointer, what happens? The sum will get bigger. There's no point. So we move the other pointer. Am I right? This is 2 pointer thing. And when the 2 pointers meet in the middle, so the total number of steps is n. Okay, when they meet in the middle, look. 1, 2. Okay, so it's actually in O(n). Okay? Make sense?
Yeah.
So the time complexity, this one is O(n) log n, this is O(n). So to sum up, add it together, the time complexity is dominated by this one, sorting O(n) log n. This one, brute force, right? This is simple, without the sorting it. So we just brute force all the pairs. There are n numbers. How many pairs?
N.
There are n numbers. Four apples, picking 2 apples. How many ways?
6.
Yeah, so it's, remember this C n2, right? Cn2. So n elements, picking 2. The order does not matter. Picking 2, 3 is the same as V2. Okay? So n apples, picking 2 apples is Cn2. This is equals to n times n minus 1 divided by 2. So this is where the O(n) square coming from. Because look, n times n, right? This is most dominating. So this is O(n) square. And all others are trivial parts. Okay, so how many algorithms have we talked about to solve this problem?
2.
2. Brute force, this one. This 2 pointer thing we have talked about early days when finding the exact pairs, right? It's similar, it's the same, except this bit, okay? It's similar. Except that question is different. This question is to count how many pairs whose sum is less than the target. There are quite a lot of variants. One is to find if there are two numbers added up that equals to target. Or we want to find out the maximum sum less than target. We want to find out if there are two numbers added up together which is less than k, and still we want to get the maximum. Okay, so there are quite a lot of variants, but these kind of problems can be all solved by using two-pointer that requires the arrays to be sorted and the time complexity is O(n) of n. And by brute forcing, it's going to take O(n) squared, because brute force all the pairs takes O(n) squared time. Picking 2 apples out of 3 apples. Picking 2 apples out of 100 apples. Cn2. Can you sum up what have we learned today?
We got
Yeah.
numbers, array,
Mm-hmm.
an array of numbers, and we have k.
Picking two numbers, finding the amount of pairs which has a sum of less than the target.
That's right, yes. And how can we do it? How many ways we can solve this?
2.
Okay, so the first one is
Brute-force sorting thing.
sorting thing. And how can we sort it? Why do we need to sort this array?
So we can do the 2-pointer thing.
Okay, so let's say if I have left and right pointers. If the sum is less than target, what should we do? If the sum is less than target, what should we do?
Move left, right.
Move the left pointer to the right. How many pairs we have?
R minus L.
Yeah, because if we can move these R left, and all these pairs are smaller than target, right? The sum is smaller than target. Okay, so on the other hand, if the sum is bigger than the target, bigger or equal than the target, what should we do?
Move right, left.
Yeah, move right, left. Because if we keep moving left, right, then the sum will get bigger. There's no point, right, to check that, right? So we need to move the right, left. Okay, that's it for today. Bye bye. Bye bye.